Okay, now for probably the hardest part of chapter 4, when we do transformations. Okay, so we've done transformations before, some of it you know about. Remember that your original shape is the pre-image, and any reflection or translation is called the image. Just make sure you remember the difference between the two. Okay. Congruent transformation, don't forget, if you are transforming any shape, in this case most of the time it will be polygons, make sure everything is in proportion, is the same size. Congruence, remember, is same size angles, same side lengths. And then obviously the three that you do know about: reflection, translation and rotation. Okay, identifying, don't forget your original figure or pre-image goes on to an image. If you use the same letters, so for instance, if I wanted to use ABC again, don't forget it's A dash, and then it'll be B dash and C dash if I was looking at my diagram, similar to what they've drawn. So remember, it's either change the letters or change the fact that it's going from A to A dash, or if you're translating it again, A double dash. Okay, other thing, don't forget, we've talked about this line of reflection so many times. Okay, well, don't forget we can also have it in transformations as well, but this time it's called the line of reflection. Okay, 2 of the 3 that you use a lot of: translations. Sometimes you'll see in textbooks as slide. Both answers, if you are answering a question, if you put slide instead of translation, doesn't matter, you will still get the grade, you'll still get the marks. All right, and then finally rotation, and if you rotate, there will always become a center of rotation. Don't always think that it's going to be the origin 0, 0. There will be parts in this part of this exercise where you will be able to calculate where the center of reflection is. And if you have a look at the diagram here, the length from T to the point and Y to the point, again we've got this little notation that it must be the same distance. And here are the 3 different types of translation. First one, a reflection. Okay, second one, a translation, rotation. So let's have a look at the diagrams that they've given, the examples. Well, question number 1, we have this center of rotation, so this is a rotation shape. Again, here we've got the y-axis is the line of reflection, so here this is a reflection, and even though this is going across and down, it's still a translation, or don't forget you can use the word slide. So here is the questions it's asking you to identify the type. Is it a reflection, a translation or a rotation? Well, have a look at the question number 1. This is going across and it's going up. It's a translation. So have a look at number 2. Well, if you take this arc here, it actually reflects into this arc here. So here is your line of reflection. So this guy for question number 2 is a reflection. So real life pictures to again find out whether it's a reflection, a translation or a rotation. Love this number 3, look at that beautiful picture. But again, if you think about it, you've got a line of symmetry here. So this is a reflection. And obviously this Ferris wheel, you know it's going in that direction, could be going in the opposite direction, it doesn't matter, but that is obviously a rotation. Everyday items that you will see, translations. Okay, the big part of transformations. You know, as usual, we've got it here with vertices. You've got 3 points here, and it is translated to 3 points here. So you've got 2 triangles. You know me, and I love the way the question asks. It says graph the original figures and the image, and then identify it. Well, let's have a look at what you've got to do. Obviously, you've got to graph it. Okay, from the graph, you cannot make the distinction that it is congruent, you have to prove it. And how do you prove it? The good old distance formula. If you can prove all three sides are congruent, then you can say, and only then can you say that the two triangles are congruent by side, side, side. Okay, so here's an example. You've got the same triangles, the two triangles that was on the previous slides. When you plot them out, as you can see, you really can't determine. You can probably have a rough guess because you know that if you make right angles here, you've got that same distance. You can do that all the time. But use the distance formula. It doesn't take you a few minutes to do all 6 sides. But again, leave them in radical form, because you know me, the more you do mathematically, the more chances you've got of getting things wrong. So you've got 2 root 17s, you've got 2 root 29s, and you've got 2 root 40s. So all 3 sides are congruent by side, side, side. Now you can make